Okay, this is the video on geometric sequences and series. You also need this part for your SAT. So make sure you know the formulas that were given earlier, so you can use those. They're in the book as well. The first thing we have to do is show that each sequence, make sure you're on page 857. We have to make sure that each sequence is geometric, find the common ratio, and write out the first four terms. So to find that if this is geometric, what we're going to do on number 5 is write this out as the next term over the current term, which we can rewrite as 3 to the n plus 1 minus n. Remember, when you bring this up, we just change that to negative. Have a common base here, which equals 3 to the first term, which equals 3. So we do have a common ratio. And what else do we have to do? The common ratio is 3, and write out the first four terms. So the first term would be 3. 3 squared is 9. 3 cubed is 27. And 3 to the fourth is 81. And if you take any of these, say 81 divided by 27, or 27 divided by 9, or 9 divided by 3, you would get the common ratio here, which equals what? 3, right there. All right, let's do 7. We have negative 3 times 1/2 to the n. So that means it's our current term. And what we're going to do is first determine if it's geometric. So we're going to set the next term over the current term. And that would be negative 3. So the ratio is negative 3 to the 1/2 n plus 1 over negative 3 to the 1/2 to the n. Now, the negative 3's would cancel here. So basically we get 1/2 to the n plus 1 minus n, which gives me 1/2. All right, so my common ratio is r, and now all I have to do is write out the first few terms. So I'm going to let r be 1/2, and if I let r be 1/2, I'm going to get negative 3 for my first term. I'm going to get negative 3 to the 1/2 to the first power, which is negative 3/2, and a sub 2, which is be negative 3 over 4, because you're just going to square. This is negative 3 to 1/2 squared, so you're just squaring that. A sub 3 would be negative 3 over 8, and a sub 4 would be negative 3 over 16. So those are pretty easy, and you just plug them in, and you must show your work on your problem sets. Okay, the next set we have is we have to determine if it's arithmetic, geometric, or neither. If it's arithmetic, find the common difference. If it's geometric, find the common ratio. So we first have 15, and you can kind of clearly see that this is linear in terms, so it's arithmetic. But all you're going to do on 15 is just say that we're going to do the current term. So we have n plus 1. If we just write out some terms, we're going to get 3, 4, 5, 6. Clearly, it's a common difference, which equals 1. All right, and the ones that have now this one, let's look at one that's neither. So let's look at 17. 17, we have 4n squared. So in 17, we're going to look at just plugging in some values. So if you plug in 1, we get 16. No, you plug in 1, you get 4, then you get 16, then you get 36, then 64, then 100, and so on. There's not a common difference, but neither is there a common ratio. The ratio here would be 4, and the ratio here is just 36 over 16, which is clearly not 4. So this one is neither. So when it looks like a quadratic like that, it's neither. When it looks linear, there's a common difference. And then when it looks like an exponent, like say 23, we're going to have 2/3 to the n. That's clearly going to have a common ratio, because we could write this as 2/3 to the n plus 1. That would be the next term over 2/3 to the n, which, as we saw on the other problems, that's just going to be 2/3, which is a common ratio. And you could write out some of the problems. You'd get 2/3, get 4/9, 3 would be 8 27ths. And if you divided these, you could just look at this and say multiply each piece by 2/3, and you'll get that. So if I multiply this last bit by 2/3, we'll get 16 over 120. That's going to be what? 2 and 6 is 81, and so forth. So that's clearly geometric. Okay. Now, the kinds that are going to really be on your test are, we got to find the fifth term and the nth term of the geometric sequence whose initial term, a, and the common ratio are given. So we have 25. So in 25 we have, let's see what it is. 25 says a, which is the first term, equals 2, and r equals 3. So in 25, all I'm going to do is use my formula. What do we have to find? The fifth term. So a sub 5 equals a sub 1 times 1 minus r to the n over 1 minus r. And that's going to give us, why do they say this? Why do they do r is 3 on 25? So am I writing this down right? Oh, this is 29. So let me make sure this is 29. Sorry, we're on 29. Okay, so when I work this out and use the calculator, I'm going to get 2 times 1 minus 3 to the fifth power over 1 minus 3. And if you simplify all that, you're going to get 162. Now, we also have to write the term for it, so the nth term. So the nth term in general would be a sub n equals 2 times r to the n minus 1. Your general formula for these are a sub n equals your first term times your ratio to the n minus 1. And that's the general formula. So just make sure you know that. All right, let's do another one. Let's do 31. I don't like let's do 31. So 31, we have the first term is 5 and r is negative 1. So if we just want to write out the terms like we did before, a sub n equals a times r to the n minus 1. So we're looking for the fifth term again, right? So a sub 5 equals 5 times negative 1 to the n minus 1. Okay? And that's all you have to do. What else do we have to do? Oh, we have to find the sum. So we're going to use our formula, a sub n equals a times 1 minus r to the n over 1 minus r, which equals 5 times 1 minus negative 1 to the fifth power, we're looking for the fifth term, which is going to keep that negative over 1 minus r, negative 1, which is actually going to be 2. So when you work all that out, you're going to get 5. All right. Now the next one is 30. Well, let's just move on because those are really easy. Find the indicated term. So we have to find, and we've already done these before as well, the ninth term. Let's do 39. The ninth term of, oh, this is easy, 1, negative 1, and 1. So what do you think it's going to be? All our odd numbers are going to be what? 1. So our answer should be what? 1. I'm just going to do that one that way. Use some of our mental math. Let's do 37 then. 37, we have 7th term of 1, 1/2, 1/4. Clearly the common ratio is 1/2 because you just have to keep multiplying. The next one would be what? 1/8. Our first term is 1, and we have to find the fifth term and the nth term. So the fifth term is going to be, you already can tell it's going to be 1 over 32, but anyway. So for 37, we're going to do n is 7. So we have ace of 7 equals 1, that's your r, times 1/2, your common ratio, to 7 minus 1, which equals 1 times 1/2 to the 6th, which is clearly 1 over 64. All right. Do it anything else? No, that's it. All right, let's do one more. Let's look at a scary one. Let's do 41. 8th term of 0.4. I'm going to put the 0 in front to be professional. 0.04 and 0.004. So for this one is 41. So all I'm going to do is notice that the first term is 0.4, 0.4. And our r is 0.01. 0.01. All you have to do is divide this by the previous term, or this by this one, you get 0.01. We want the 8th term, so we're just going to write our little formula. That's going to be 0.4 times 0.1 to the 8 minus 1, and that's just going to yield 0.1, 2, 3, 4, 5, 6, 7 to the 4. You have 7 zeros there because that's to the 7th. Or you can use your calculator. All right. The next set is we have to find the sum. Okay, so that means we're adding, that's a geometric sum series, and we have 43. So we have 1/4 plus 2/4 plus 2 squared fourths, which is actually just 1, plus 2 cubed to the 4th, plus ... 2 to the n minus 1 over 4. And this one is 43, so all we're going to do is determine that a equals 1/4, our r equals 2, because we'll just keep multiplying by 2, and so our sum equals a to the r minus r to the n over 1 minus r. That's going to give us 1/4 of 1 minus 2 to the n over 1 minus 2 this equals 1/4 times 2n minus 1. And I just cleaned up my negatives there. Okay? Now 44, or let's do 45, because 45 is the kind you're going to have on your test, because I want you to make sure you know your summation signs. So 45, we have k equals 1 to n, and we have 2/3 to the k. So in 45, we have A is 1, because the formula generally is A times R to the K minus 1, or it could just be K in this case. So basically, what do we have to do? We have to find the sum. So on 45, I'm going to notice that my A is 1, my R equals 2/3, and you're just going to find the sum for it. So the sum equals 1 times 1 minus 2/3 to the n over 1 minus 2/3, which this just equals 1/3. And clean it up, and you're going to get 2 times 1 minus 2/3 to the nth power. Okay? That's how you do those. Let's see. We got to do infinite geometric series. We have to find the sum of each infinite geometric series. So the first one is 55. We have 1 plus 1/3 plus 1/9 plus ... First of all, is it infinite? And the way you know if it's infinite, if you have -1 is less than r is so r has to be between -1 and 1, and it definitely can't be 0. So you can write that if you want. So basically, it's a proper fraction, and we're going to use our simple formula for 55. The simple formula is the sum, the infinite geometric series is A over 1 minus R. So the sum is going to be A is 1 over 1 minus 1/3, which equals 1 over 2/3, which equals 3/2. Very simple. 50, let's do 57. Let's do one with that's written out. Let's do 61. We have the sum of k equals 1 to infinity, so it's an infinite series. K minus 1. So the sum, infinite sum formula is going to be A over 1 minus R, which equals 5 over 3/4, right? Because this is 4/4 over 4. 3/4, which equals 20 over 3. And that's all. Pretty simple. You want to do another one, we can. Let's do 63. On 63, we have k equals 1, and we're going to infinity. And we already talked about what that means. K minus 1. So basically, I'm going to find the sum. So A is 6. R is -2/3, so that's going to be plus 2/3. So we're going to have 6 over 5/3. Oops, 6, which equals 18 over 5. And that's it. The next video will be that we'll be going over next class will be mathematical induction.